you, Eyal, for organizing this session, and thank you, everybody, for being here. Yeah, so this work has been done jointly with Yan Zhang, who's also in this session, I saw. And as the title suggests, the paper is about, looks into the long-term health effects of giant oil fields, giving some evidence from China. Right, so starting with the main question and the motivation. So our main question is whether oil discoveries and production may carry long-term health consequences. And motivation comes from examining the wealth-health trade-off of oil discoveries and production in the long term. And so just to say a few words about that. And so as we know, at the local level, oil discoveries and production induce development on one hand, such as say, improved infrastructure and health services. But on the other hand, they may also carry health consequences such as pollution. And so the literature so far considers this trade-off mainly within the short term. And apparently very little attention was given to this trade-off within a long-term context, and especially with regard to long-term health effects. Related studies, and that's from other fields such as public health and epidemiology, examine this at the cross-sectional level, and so they didn't account for whether individuals lived elsewhere prior to the study, which implies that their health may have been affected by other shocks, not necessarily the oil fields. And so the challenge for estimating, or one of the challenges for estimating long-term health impact, is being able to track the location of individuals throughout their life, which is essential for being able to consider individuals that lived in close proximity to an oil field over a prolonged period. And so in this paper, we fill this gap by estimating the long-term health impacts of oil discoveries and production in China. And we do so by examining the health outcomes of individuals that lived in the same location throughout their lifetime. And that's by exploiting a unique feature in the Chinese surveys that I'll talk about next. So quick overview. In this paper, as I said, we study the impact of oil discoveries and exploitation on the health consequences of individuals in the long term. And in terms of the empirics, we use data on discoveries of giant oil fields in China from 1938 to 2018. And we employ a detailed individual data from what's called the China Health Retirement Longitudinal Study, or in short, CHARLS, which covers about 20,000 individuals across 125 Chinese cities, and it's representative of the Chinese population aged 45 and above. Where the idea is that we consider individuals' proximity to discoveries, spatial analysis, and we estimate the impact of the closest discovery on a multitude of health outcomes in the survey year. So most discoveries were done during the 60s and 70s, and we look into the impact on health outcomes in the survey year, which is between 2011 and 2018. That's the long-term perspective, and we do so by a diff and diff approach, where we compare between those born before and after discovery. Our identification strategy is based on a difference in differences design, where the treated population is those that live in close proximity to a discovery, and the treatment is the discovery itself. Identification is based on the plausible exogeneity of the timing, location, and exploitation of discoveries. And it's based on the unique feature of CHARLS, which is identifying individuals that never moved throughout their lifetime. Right, so going over the main results very briefly. So we see that discoveries made within a range of 60 kilometers decrease the average long-term health conditions of individuals born after the discovery. And although, as the data shows, these individuals are younger, they are happier, they smoke less, and are born into a more developed environment. The magnitude is fairly large. We see that a giant oil field discovery induces an increase of about 25% in the average share of individuals born after the discovery who are diagnosed with a chronic disease. So we have a list of about 14 chronic diseases, and this is related to these chronic diseases, which I'll mention. And that's compared to those born before the discovery. And we see that these patterns are observed most strongly in health outcomes related to chronic lung diseases, heart disease, chronic kidney and stomach diseases, and what's called also the BMI, the body mass index, which is related to being overweight. Last, we see that these patterns also hold when we move into the production phase, not just looking into discovery, So usually discoveries move into a production phase on average after 5 years. So very, very briefly about the literature, we contribute basically to two main large literatures. The first is the one on the long-term health effects of early life shocks, where our main contribution is that we examine the impact of a new factor, which is giant oil fields. And the second literature, large literature, is the one on the effects of resource shocks and abundance, where we look into the impact of resource abundance on long-term health, which seems to have been overlooked in the literature so far. Right, moving to the data. We have two main measures in the exercise, as I said, giant oil fields and the Charles survey. So just to very briefly describe both. First is data on giant oil discoveries. So we use data from Horn, who recorded all discoveries of giant oil fields from the late 19th century to 2012. He defined the giant oil field to be one for which the estimate of ultimately recoverable oil is at least 500 million barrels. These fields have a production lag of about 5 years, as I said, and once producing, they operate for about 50 years on average. Why do we use giant oil discoveries? First, their timing, location, and exploitation are plausibly exogenous, and by that we follow the approach of previous studies. We know that they provide a major economic shock, again, been reported in previous papers. And last, we also know that they've been shown to affect air pollution, water pollution, and environmental contamination. And so they're expected to have an effect on long-term health. Our sample focuses on discoveries made in China. And we have altogether 37 discoveries. First one made in 1938, last one in 2006. The majority of discoveries that were next to cities were done in the 60s and 70s, and 4 of them were offshore. Right, so this figure just gives the distribution of discoveries across China. So we see the red dots are the discoveries, and the gray areas are the 60 kilometers radius, which is what we call living in close proximity to a discovery. Next is the Charles survey. So this is a rich health survey on a representative sample of Chinese residents age 45 and above. There were 4 waves made for this survey in 2011, 13, 15, and 18. And in 2014, there was another wave, which was called the life history wave, where they gave further personal measures other than health. We exploit a panel of all the available years. And so in each wave, respondents answered a detailed questionnaire related to their health and also other demographic, personal circumstances, and economic conditions. And this includes the existence of chronic diseases, weight, mental health, physical abilities, health during childhood, parental health, and others, and also other economic factors such as income and others. We look into all these measures, but our focus mainly is on the objective health outcomes, which are the diagnosis of chronic diseases and the BMI, which again, being overweight, as these enable making clearer inferences. In addition, the survey uniquely tracks the location responses throughout their lifetime, which is essential for our exercise, as I mentioned. So the survey lets us know whether individuals lived for more than 6 months in a different location throughout their life. Fortunately, about 80% of the sample haven't moved throughout their life, and that's because the survey looks into the more elderly population. So our sample includes about 20,000 never movers in 125 cities, and using this survey is appealing because one, it has a wide coverage of health outcomes. It identifies individuals' location, and 3, it focuses on a proper sample for studying long-term health outcomes, which is the middle age and older population. Finally, it's also been used in previous studies to study long-term health impacts. Right, so our methodology is a standard difference in differences approach. Treated group is those living in close proximity. The treatment is the discoveries. And the meaning of this is that we compare between the differences in the effects in the long-term health outcomes during the survey year of individuals that were born before and after discovery. So we do a within city analysis where we compare between those being born before and after, and we do this across proximities, those living close and those living far from an oil field, where the main conjecture is that the long-term health impacts of a giant oil field located close increases with the fraction of years exposed to it. So individuals born after discovery were by definition exposed to the oil field 100% of their life, whereas people born before were exposed to it to a much lower fraction, sometimes 10% or 20% of their life, and that's the variation we look into. In terms of proximity, we measure this by the distance of the closest discovery to each individual in the sample, where we define close proximity to be within 60 kilometers of a discovery, and that's based on the results, which I'll show in a few minutes. That's a distribution of individuals across distance. We see that there's about 1,300 individuals that live in close proximity in our sample. That's a distribution of individuals across the discovery threshold. So we see that about 4,000 individuals born after the discovery. Right, and that's our baseline specification. So to describe it briefly, what we have on the left-hand side is the health outcome variable. So we look into a few outcome variables, which I'll outline in the next slide. Before is a dummy for being born before the closest discovery. Close is a dummy for living in close proximity. And X is a vector of controls that includes also the age, which is an important control. And we also have CT and wave fixed effects. And our focus is on gamma here, which is the coefficient on the interaction, which gives us the estimate for the long-term health impact of a giant oil field. Right, so outcome variables. We look into 5 main variables, but our focus is on the first 2 outcome variables. So the first one is the health index, which is the average of the existence of 14 chronic diseases, going from hypertension to cancer, to asthma. So individuals reported whether they were diagnosed with one of these chronic diseases at the time of the survey, and we look into an average of that. Second measure is being overweight, which means having a BMI higher than 25, which is the standard definition for being overweight. Then we look into disabilities, whether the individual has physical or intellectual disabilities, vision, hearing, or speech impediments. Mental health, whether it has depression, mental attackness, so on. And then finally, childhood health, which is a self-reported measure for whether health was good during childhood. One point relates to the earliest diagnosis. So people in the survey reported whether they were diagnosed with a chronic disease during the time of the survey, where the diagnosis was many times done in earlier years. So we just showed the distribution of the earliest diagnosis to show that this was done during adulthood, which means that our interpretation for long-term is applicable. And we also control for the earliest diagnosis directly. Identification, as I mentioned, is based on the exogenous nature of discoveries, on the focus on individuals that never moved, and the identifying variation is the discovery-triggered difference in the differences in the outcome variables across proximities. And as we know, that's dependent on having common pretrends. So just to show the common pretrends, what we see here on the left is the common pretrends in the overweight measure, and the right is the pretrends in the health index. And what we have here are the averages for each measure, the overweight and health, in age beams, pre and post discovery. So the discovery was made in time 0, and we have the age beams to the left, those that were born up to -5 or -15, and so on, and the same to the right, where the circles are the averages for those that were born close to a discovery, and the X's are those born far. And we just compare the averages, and I think the figures speak to themselves, but by showing that prior to a discovery, we see that the averages are pretty common in both cases and in both measures. Whereas at the time of discovery and afterwards, we see that there's a clear divergence there between the averages, and that's the variation that we exploit in the exercise.
5 minutes, Ohad.
5 minutes, okay. Right, so the initial main results. So these figures tell the story. What we do here is that we estimate variation of the model I explained before, only instead of having the close dummy, we break it down into this distance vector, which is distance beams. different distance beams, so 0 to 30, 30 to 45 kilometers, 45 to 60 from the discovery, and then we estimate everything concurrently in one specification, and we plot down the gammas. What we do here is that we plot down the gammas with 95% confidence intervals, and what these figures show, well, they give the main results, is that first of all, distance matters. So we see that in both cases, what matters is the threshold of 60 kilometers, where in the case of overweight, we see that up to 60 kilometers, individuals that were born after the discovery are relatively, or their share, they have a larger share of overweight people. And in the case of the health index, individuals that were born after a discovery, again, up to 60 kilometers, have been reported to have more chronic diseases. After the 60 kilometers, we see that the effect is close to zero and is non-significant. Right, this is the baseline results of the baseline model, but I think what's interesting here is just columns 1 and 2, which looks into the overweight and health measures. The patterns here are exactly as described with the graph. The difference is that here we can give some interpretation to the magnitude, which is interesting. What we see is that a giant oil field discovery induces an increase of about 25% in the average share of diagnosed individuals born after the discovery. And that's compared to those born before the discovery, which is a fairly large impact. Right, so here what we do is that we disaggregate the health index to the different 14 measures, and we just estimate them separately. And what we see is that the main patterns are driven mainly by chronic lung disease, heart disease, and kidney and stomach disease, which is consistent with the reported types of environmental pollution induced by oil fields, such as air and water pollution. Then we do some heterogeneous effects, and we see that effects on BMI are weaker on educated and older individuals, and the effects on health are weaker for males. Then we look into some potential mechanisms. So here we change the dependent variable for testing different potential intermediate channels, such as smoking, drinking alcohol, doing exercise. And what we learn is that individuals that were born after discovery and live in close proximity tend to drink more alcohol, and that's consistent with our interpretation is that it's consistent with the wealth effect. Then finally, we do some robustness and additional tests where we control for the earliest diagnosis, we restrict the sample to post-discovery diagnosis. We examine the complete sample, not just the non-movers, but also those that moved, which gives us about 21,000 individuals. We exclude the 8 major coal cities. So coal production is a big thing in China. And so we exclude the 8 cities that are considered to be major coal producers. We consider the size of the discovery through the present value, not just as a dummy for whether there was a discovery. And then we also adopt a different treatment, not discovery, but moving into the production phase. And in all cases, we get the same patterns.
Time to finish, Ohad.
Conclusion. Okay, yeah, so in this paper, we examined the long-term health impacts of giant oil fields through the case of China. We looked into giant oil discoveries and the Charles survey. We took a difference in differences approach. Identification was based on the exogenous nature of discoveries and the focus on individuals that never moved. And our main result is that giant oil fields deteriorate the long-term health conditions in what seems like a fairly large magnitude, despite the positive wealth impact, and they do so by primarily affecting the respiratory, digestive, and urinary systems. And sorry for going over time if I did, but thank you.